Welcome to Learners Forum. So in last video, we saw about the introduction and types of number system. In this video, we will be seeing about the conversions of number system. So we have different types of conversions like decimal to binary, decimal to octal and many. And now we will see about as the first conversion from decimal to binary. So decimal is represented with base 10 and binary is represented with base 2 as we have seen in the last video. Now to convert from the decimal number to its equivalent binary number, we need to know certain rules. So it is given by integer part and fractional part. So in case if we have only integer part for any number, then we have to divide it by the corresponding base value. In case when it has a fractional part, we have to multiply by its base value. So these are the rules and now we will follow for the given example. So for the given example, 13 is purely an integer part, that is it does not have any decimal number. So first we have to divide by its base value. We have to check if it does have a decimal number, and after the decimal number, if it has a digit that belongs to fractional part. So since it has only integer part, we have to divide by its base value, which is 2. So 13 divided by 2. So first, if we start dividing, we have to divide until it reaches the value less than 2. So first, let's divide 13 by 2. So 2 6 are 12, remaining 1. So that is kept aside with the number 1. Next, again divide the 6 by 2. So 2 3s are 6. It does not have any remainder. So we have 0. Next, divide 3 by 2. So 2 1s are 2 and the remaining 1 is kept aside. So we will have 1 at the other end. And once after dividing, we have to check if the last digit is less than 2. 1 is less than 2. So we have to stop the dividing process. Now once after this completion, we have to draw an arrow mark starting from the last value, which is 1, and move it upwards like an inverted L. So this structure of L will give you the equivalent representation for the given value. So starting with the last digit of 1, we have to move along the direction to make its equivalent representation. So 1, next 1, 0 and 1. That is the equivalent representation for the given decimal number 13, which is 1, 1, 0 and 1. So this is how we will be converting a decimal number into its equivalent binary number. Now let's see one more example where we will have both the integer part and the fractional part. 57.25. So 57 will represent the integer part and 25 will represent the fractional part. Before the decimal represents integer and after the decimal represents fractional part. So as we have seen, integer part we have to divide by its base value, and for fractional part we have to multiply by its base value. So the integer part we will convert now. 57 divided by 2. So 2 2s are 4, remaining 1 70, 2 8s are 16, remaining 1. Next 28, so 2 1s are 2, 2 4s are 8, we will not have any remainder, so 0. Next 2 7s are 14, no remainder, so 0. Next 2 3s are 6 and we will have one remainder, so 1. Next 2 1s are 2, remainder 1, so again 1, and we cannot divide further, so we have to stop and we have to draw an arrow mark moving upwards. So integer part's equivalent value is now completed. Next we will move to the fractional part, which is 0.25. So 0.25 we have to multiply by its base value. So 0.25 into the base value is 2. So 0.25 into 2 is equal to 0.5. So now we have to take the value in front of the decimal, which is 0, and keep it aside. Next we have to consider the digits after the decimal. So 0.5 into 2, and which is equal to 1.0. Now again in front of the decimal we have 1, so take it aside. Next 0.0, which is after the decimal point, that is multiplied by 2, which is equivalent to 0. So we will have 0. So we have to repeat until the value gets 0 or we get repeated values. And now we have to draw the line from the first value, which is moving downwards. So that is the representation for the fractional part. So the equivalent representation, now we will be following this particular arrow mark. So it is 0, 1 and 0. So this is the way we convert a fractional part of a decimal number into its equivalent binary number. So 57.25, for 57 we have got, and for fractional part 0.25 the equivalent value is also obtained over here. So the net solution is 1110001 for integer part, and for fractional part it is 0, 1 and 0. So this is the equivalent binary value for the given number. Now let us solve a third example, 129.75. So this decimal value has to be converted to its equivalent binary value. So first we will identify the equivalent decimal value for 129, which is the integer part. So divided by 2. So 2 6 are 12 and 2 4s are 8, remaining 1. Next again dividing it by 2, we will have 2 3s are 6, 2 2s are 4, no remainder, so 0. Next again divided by 2, so 2 1s are 2, remaining 1, so 2 6 are 12, so no remainder, again 0. Next one further dividing, 2 8s are 16, no remainder, 0. Again 2 4s are 8, no remainder, so 0. Next 2 2s are 4, no remainder, so 0. Again 2 1s are 2, no remainder and 0. We cannot divide it further. So now we will draw our arrow mark starting from the last value, which is moving upwards, so that we can identify the equivalent representation for the integer part of 129. Next we will move on into the fractional part, which is 0.75. So for that we have to multiply by the base value, which is 2. So into 2, which is equivalent to 1.50. So in front of the decimal we have the value 1, so keep that aside. Next, remaining decimal point remaining value is 0.50 into again 2, which is equal to 1.0. So 1.0, again we have 1 in front of the decimal, so we can keep that aside. Next, the remaining portion behind the decimal point is 0. So 0.0 into 2 will give again 0.0. So the last term is going to be 0. And once after this, again we will have only zeros. So we can stop with this and we can form the tracing path. So by moving downwards, we have the path. So the decimal equivalent for the given number 129.75 is going to be, for the integer part we have 1 0 0 0 0 0 1 point. Here we have 1 1 and 0. So this is the equivalent representation for 129.75, the given decimal number, and this is the way we have to convert a given decimal number into its equivalent binary value.